Hello, this is part 3 of the limits video. In the last one, we talked about this basic technique of factor and cancel if you see you have 0 over 0. Now we're going to see a few wrinkles on this. So sometimes before we can do the factor and cancel, we need to do additional simplification. Right? So anything in your algebraic toolbox that allows you to rewrite something could be relevant. Maybe you need to FOIL something out. Maybe you need to group like terms. Maybe you need to simplify some things with fractions. Right? But just do what you need to do to make your things look a little more simplified. So then maybe it's more obvious what can cancel. Right, so here's an example to watch. Right, we have this rather complicated looking thing that has fractions within a fraction. And let's just check what happens if we plug in. If we plug in x equals 3, I have 2 over 9 minus 2 over 9 over 3 minus 3. That's 0 over 0. So do keep in mind, when you see 0 over 0, probably something will cancel, but you need to be clever about simplification first. So here is what I would recommend. If you see fractions within a fraction, you should say to yourself, that is unsimplified. I want to change this. And I certainly don't want to see two fractions in the numerator or two fractions in the denominator. So I would look at this, fraction minus fraction. That's a complicated element here. And I would say to myself, can I combine these? At the very least, can I take that expression, which is one fraction minus another fraction, and just write it as a single fraction? And hopefully you remember you can subtract fractions as long as they have a common denominator. So we're going to create a common denominator. So for now, I will leave my denominator for the whole thing as x minus 3. For this part, I have 2 over x squared. Here I have 2 over 9. So over here I will multiply top and bottom by 9. Over here I will multiply top and bottom by x squared. So I'm creating this common denominator of 9x squared. So now I still have x minus 3 in the bottom of the whole thing. But now over here I have 9x squared in the bottom. And this is 18. And this is 2x squared. So I have 18 minus 2x squared. So now we still want to see if we can do something to that. We might notice that 18 and 2x squared are both even, so we can factor out a 2. 2 times 9 minus x squared over 9x squared. And then 9x squared cancels. But not cancels, factors. So 9 minus x squared factors. So this thing here, it's a difference of perfect squares. That's 2 times 3 minus x times 3 plus x over 9x squared over x minus 3. Now, some people have better intuition for this than others. This whole numerator is a fraction. Sometimes people, to create a sense of balance, they just want to write over 1. So then we can look at this whole thing as it is a fraction divided by a fraction. And hopefully you remember that to divide fractions, you multiply by the reciprocal of the one on bottom. So what we have here is 2 times 3 minus x times 3 plus x, all over 9x squared. Here it is all factored out, times the reciprocal of the bottom. And hopefully we see something here that can cancel. There is a little bit of a trick here. This is x minus 3. Probably we want that to cancel. Right? As a rule of thumb, if you're getting 0 over 0 with x minus 3, with x approaching 3, then probably something with a 3 will cancel. Here we have 3 minus x. So let's just note something here. Generally speaking, x minus 3 is not the same as 3 minus x. So we can't just say, oh, they're the same thing, we'll cross them out. But they are opposites. Let's just notice, if we multiply x minus 3 by a negative, that's negative x plus 3, which is the same as 3 minus x. So we will note that quantity x minus 3 and quantity 3 minus x, if I subtract in opposite orders, these are opposites. So we can still do a cancellation. We just need to realize that one is the opposite of the other. So I'm going to cancel them out. But whenever we cancel a pair of opposites, a negative emerges. So I'm going to say 2 times 3 plus x times 9x squared times 1 over negative 1. If you cancel a pair of opposite factors, somewhere a negative 1 emerges. You can put it in the numerator, you can put it in the denominator, it doesn't matter. Now, let's try doing this by intuition. Once we've canceled, maybe we can do better. So x is approximately 3. I have the number 2. 3 plus x would be 6. 9 is the number 9. X squared would be 9. And this is just the whole number negative 1. So I have 12 over 81 times negative 1, which is negative 12 over 81, which is negative 4 over 27 if you cancel that 3. This is definitely not a fraction you would recognize if you were doing this numerically. And this is not an easy problem by any stretch. But I do want you to file away that pretty much any time you plug in to find 0 over 0, some amount of algebra will get you to the point where you can cancel away what was driving that 0 over 0 and basically plug in to finish. So with that in mind, try this problem. And we did this one numerically earlier on. We had a vague sense of what it ought to be. I'm just going to ask, what is the first step? What would you do first? And so what we could do first here is we could think about common denominators. We already know this is a 0 over 0 example. I think I've hinted at that. So if you did that as the first thing, that's fine. But it's 0 over 0. Now we need to resolve it somehow. So I will create a common denominator up top. So I'll say 1 over t plus 3 minus t plus 3 over t plus 3. This is just the number 1 over t plus 2. Now I'll just remind you, you are subtracting all of that. So when you group things together, keep in mind that you are subtracting all of it. Our denominator up top is t plus 3, and we have 1 minus the quantity t plus 3. Don't just put in a minus. Think about you're subtracting that whole quantity. So when we simplify that, we have 1 minus t minus 3 over t plus 3. So that is negative t minus 2 over t plus 3, and that is all over t plus 2. You'll notice that I am making one of these bars much bigger than the other so that I understand the overall structure of a fraction. Right? Sometimes people will write these fractions like so, and it's really hard to tell. Does this mean 2 divided by 3/4, or does this mean 2/3 divided by 4? make one of the bars, the main bar, much bigger than the others. So now here's what we might notice, that this thing here and this thing here are opposites. We are allowed to cancel opposites. But if we cancel opposites, a negative emerges. So basically I could cancel this down to -1 and this down to 1, or vice versa. And now we can plug in. I may have misspoken about, we did do this one before. I think I confused the answer. So this one, I think we actually got a nice answer. Sorry about that. So now we can plug in, right? We've canceled away the problem. So this is -1. -2, more or less, plus 3 gives us a number that's roughly 1, all over 1. So this is -1 divided by 1. And after all of that work, we get -1. Right, so for this one, maybe the graphing was far easier. We graphed that thing and we saw it was close to 1. But I want you to realize that you can do the algebra. And there will be cases where we have to do the algebra because it's a little more abstract. All right, we're going to do one more wrinkle in the next video, but I want to pause it for now.